Hi there, folks. Today we're looking at permutations and combinations. And really, permutations and combinations are used kind of for the same thing. They're used to figure out how many total options I have given a certain situation, all right? So it's a way of counting the number of possibilities, the number of total options that I have, all right? The distinction between the two is a permutation is used to count the number of options when order matters. In other words, changing the order of things gives me a different option, gives me another possibility, all right? And that's what I'm doing. I'm counting the number of possibilities. I'm counting the number of options. If changing the order of things gives me a new option, a different option that I already had, well, then I use a permutation because that means order matters. Order has an effect on how many options I have, all right? And so we're only going to do this from the perspective of plugging them right into the calculator. There is a formula for permutations, but we're not going to bother with it. We're going to just go right to plugging these into the calculator. So the notation here, we've got a little n and then a p and then an r. That's the permutation of n choose r. Or sometimes I like to just say, sometimes teachers will say the permutation of n objects taken r at a time. That to me is a little bit much. I would just say n choose r. And it's just a reminder, the n is the total number of options here. So when we talk about n is how many things I have. That's the total. And then r is how many of those things we're actually going to use. So we use that word choose. All right, it's how many of the things we actually want. So if there's a total of 10 things, but I'm only getting 2 of them, it would be the permutation of 10 choose 2 to figure out my total number of possibilities. So we call this how many we choose. Okay, or how many chosen. All right? And I have a picture of a TI graphing calculator here just to show you, because I know a lot of students have some of these smaller calculators. And really, there's a probability button on here. So if you look really closely, you see this button right here that says PRB on it. If you have this calculator and you hit that PRB button, you'll see some options here, and one of them will have an NPR. It'll be that permutation button, and you'll have to scroll over and select it, okay? If you have any calculator, almost every calculator is equipped with this, all right? You just might have to look around. Look for a button that says something like, PRB for probability. Or it might say like prob for probability. Or you might have a menu somewhere that has a PRB. So you might have to hunt around, search for your calculator. If you can't find it on there, the Schoology calculator, which I'll show you in a little bit, also has it, okay? So if I look at this first one, and let me get rid of my calculator here for a second. All right, so with that guy gone, taking a look at this guy, it says 5 permutation 2, so 5 choose 2. In other words, if I had 5 total things, but I was just picking 2 of them, how many different ways could I arrange the things? How many different orders could I put them in, okay? And so that's the idea here. This is going to help me calculate how many possibilities there are, okay? And so I'm going to pull up this is my big Casio calculator. I'm just going to use this one because I have it on my computer here to display. And my probability menu is actually under here. It's under options. It's buried in here somewhere. See, mine says prob for probability, okay? And notice when I click on that, I have the same options that you probably found on your smaller calculator, okay? But when you punch this in, you have to punch it in the way it's kind of written here in the problem. I hit the 5, then I hit the permutation button, and then the 2. And then I hit enter, okay? You have to punch it in that order, and it gives me a 20 here. Okay? In other words, if I have 5 different things and I pick 2 of them at a time, it means there are 20 different arrangements I could make. I could take the first 2 things and I could switch the order. That's 2 arrangements. So then I could do different things. So there's 20 different ways I could do this. Okay? I'm using the Schoology calculator. Let me pull that up. Oh, it looks like I had already punched this in once to test it. Let me close that out. But if you're in a Schoology assessment, and I have the calculator enabled, it's over here off to the side. If you hit the calculator button and you pull that up, the nice thing about this particular calculator is it prevents me from punching it in wrong. Notice right now I see PRB, but I can't click on it. It won't work, okay? Because I have to start typing first. I have to put in the 5 first. I hit the 5. Now I hit the permutation button and then the 2. And notice it displays it a little funny here, but still the same thing. Hit the 5, permutation button, then the 2, and then hit enter. And there it is. There's the 20. Okay? If I look at the next one, again, I've got 12 permutation 3, so I'm going to hit the 12, and then the permutation button, and then the 3. Again, it's in that PRB menu, and that gives me 1,320. Okay, which means if I have 12 different things to choose from, okay, 12 different total things, if I just pick 3 of them, picking any 3 at a time, I could keep picking 3 and rearranging them, and I could come up with 1,320 different ways that I could arrange the thing, okay? And once again, let me show it one more time on the Schoology version. So again, it was 12, now the permutation button, then the 3, enter, okay? And so here's an example where order matters, okay? There are 10 finalists in a math competition. How many ways can gold, silver, and bronze medals be awarded? And so when you think about it, we're talking about first, second, and third place. And the idea here is if I switch the order, all right, let's say I got first place, you got second place, and your friend got third place. If we switch the order, you got first place, I got second place, and your friend got third place, that's completely different, all right? We're getting different things. The outcome has changed. All right, so order matters in that situation because when I change the order of things, all right, it gives me a different result. All right, so that's why it's a permutation. And so when I look at this, I need the total number. The total number, there's a total of 10 finalists, right? So it's the permutation of 10. But then how many are being awarded here? How many are we choosing to award? Well, the answer to that is 3. Gold, silver, and bronze. First, second, and third place. Okay? And now I can punch it in my calculator. 10, permutation, 3. And there's 720 different ways that this could end up happening. Okay? If I look at the next one, once again, how many ways can a class of 12 students be arranged in 12 seats? The giveaway here for order mattering is this word arranged. And look for those key words. Arranged literally means to put things in order. So if it says, hey, I want to arrange these things, I want to put these things in different order, well, that means automatically that order matters, okay? And so what I have here is I have 12 total students, right? Or 12 total seats. There's 12 options for seating. And there's 12 total students. So it's the permutation of 12, choose 12. And look at that. That's huge. Can't even remember the whole number. Oh, sorry, there was only 2 zeros there. Oh, boy. Numbers are hard, Mr. Jansen. Okay? So that's how many different seating charts I could make. If there's 12 students and 12 seats, that's how many seating charts I could make. That's how many different ways we can position ourselves around this room. Okay? And watch what happens if I increase the number of seats a little bit. So I'm increasing the total number of things that I have to place students into. So it just changes it. I still have 12 students, but now there's 15 seats. Now I have a total of 15 seats that I can fill, and I'm going to fill 12 of them with students. Okay, so it's a total of 15 seats. I'm filling 12 of them, so it's 15, choose 12. Watch what happens now. I'm not even going to write this down after I punch it in, because it's going to be ridiculous. Look at that. Notice my calculator here has a little E and a plus sign. That's scientific notation. It's saying 2.17945,728 times 10 to the 11th power. So this number is enormous, all right? And that's just showing you how many different possibilities this could have, okay? And so I'm not even going to write that guy down because it's a ridiculous amount, okay? But hopefully you get the point. All right. When we're arranging things, the more objects we have, and the more leniency we have, and to kind of rearrange things, the more possibilities there are going to be. Okay, and they get big very quickly. If I look at something like this guy, it says an old spinster has 12 cats. She lines them up for a creepy cat parade. All right, so we're making a nice little parade with these cats, and they can follow each other. It'll be really great. So how many creepy cat parades? Oh boy, I have a typo there. How many creepy cat parades are possible? And so again, think about the situation. We're lining things up, so we want to know the different arrangements. Anytime you're getting in line, being first in line is definitely different than being last in line. Changing the order changes the lineup. It changes the possibilities, okay? And so for this one, it's the permutation. There are 12 total cats, but only 4 of them are being chosen to line up in this parade, so it's 12, choose 4. So here it is, 12, permutation 4, and it looks like 11,880. Okay? But again, look for those keywords. The keyword like arranged means putting things in order. Lining things up, is telling us that order matters, okay? And so watch out for those things. All right, taking a look at combinations. Now, combinations are when the order doesn't matter, okay? In other words, changing the order of things still gives me the same result, all right? I don't get anything different by changing the order. That's when order does not matter. That's when I'm going to use a combination. And notice, everything here is the same. The N is still the total, and the R is still how many we're choosing. Okay? And so the idea here is really it's the same thing. We punch it into the calculator the same way. The only difference now is I use this when order doesn't matter. Okay? So if I take a look at this one, the combination of 7, choose 2. Again, on my calculator here, I can punch in the 7 and then the combination button and then the 2, and I get a 21. Okay? See, if the only thing I care about is what I'm getting versus what order I'm getting it in, that's when I use a combination. And so if I look at the next one, again, 8, choose 5. Let me do the Schoology one this time. Let me clear this guy. So I hit the 8, and then the combination button this time, and then the 5. I didn't hit an 8. Let me try again. 8, combination, 5, enter. Okay, so I get 56. So again, this is when we only care about what we get, not necessarily the order in which we get it. Okay, that's when we use a combination. For example, it says, how many ways can a team of 5 be chosen from 11 athletes? And so the idea here, so if we're choosing a team, like let's say it's me, you, a friend, and 3 other friends, all right? Does it matter if I get chosen, then you get chosen, and then those same 3 friends? Or if the 3 friends get chosen, then you, then me? Does it change the team? Does it give us a different result? And the answer is no. Changing the order in which they're picked doesn't change the outcome, okay? And so if we're choosing something like a team, all right, regardless of the order we're chosen in, we still have the same team. We still end up with the same thing. So the order didn't matter. What we get matters, not necessarily the order in which we get it, okay? So this is going to be a combination. And again, it's always the total, which is 11. And then how many we're choosing. So 11, choose 5. 11 total, we want 5 of them. And now we just plug it into the calculator. 11, combination 5. So 462. And hopefully you notice right away that these values tend to be quite a bit smaller, okay? When order matters, we have a lot more possibilities. If I look at this, a group of 7 campers are attacked by aliens. The aliens abduct 2 people and leave. How many ways can 2 campers be chosen? And so again, let's say it's myself and you. Well, it doesn't really matter the order. If it's myself and you versus they captured you and then me, all right? It doesn't matter. The result is the same. We're the 2 who aren't going home, all right? So the idea here is the order doesn't matter. Who is chosen matters. But the order in which they're chosen doesn't. So it was 7, choose 2. Okay? And I already did this one. That was a 21. Okay, that was one of the ones I did earlier. Okay? If I look at this one, it says Fred's Frozen Treats has 15 ice cream flavors, and you're allowed to choose 2. How many different combinations are possible? And so the idea here is, think about choosing flavors. If I step up to the counter and say, I would like a scoop of chocolate and a scoop of vanilla, versus if I step up to the counter and say, I want a scoop of vanilla and a scoop of chocolate, am I going to get something different? All right? And so the idea here is, let's say I'm getting a dish of ice cream, well, chocolate and vanilla versus vanilla and chocolate, I'm going to get the same dish of ice cream, 1 scoop of each. The order in which I placed those, the order in which I said them doesn't matter. I still get the same result. I still end up with the same thing. Okay? So it's the combination of 15, choose 2 this time. Okay? So 15, combination, 2, enter, and I get 105. Okay? So again, we are using our calculator to calculate the number of possibilities. The biggest thing here and the toughest thing to figure out is whether or not order matters, okay? And think about it. If I change the order, do I get a different result? Look for those keywords, arranged, lines, okay? Lining things up, all right? If you can't make a distinction, if it doesn't look like order matters anyway, assume order does not matter, okay? Most of the time we use combinations, all right? Usually there's an indication if order matters. There's one of those keywords, okay? And then when we punch this in, remember it's always the total followed by the number of things we want, okay?